All right, my dear JEE aspirants, continue with limits. This time 2021 JEE Main. All questions of 2021. All steps covered. Limits chapter. This time they conducted four sessions, I think 4 phases, because we had a devastating COVID wave in the year 2021. So JEE exams were conducted on 4 shifts or 4 phases in the month of February, March, July and August. Okay, so there are more questions in this video, this session. One by one we'll cover all these things. Take the first question. This time I started with a numerical type question. The first one given like this: f of x equal to a polynomial of degree 6 is given, x power 6 plus 2x power 4 plus x cube plus 2x plus 3x belongs to the natural number n for which this equation is satisfied. To find the natural number n satisfying this condition, limit x tends to 1, x power n into f of 1 minus f of x divided by x minus 1 equal to 44. This condition is satisfied for which value of n to find out. Numerical type question. Question asked on 1st of September, 2nd shift 2021. If you apply the limit directly, what happens? You see, when you apply the limit x equal to 1, put x equal to 1 power n, that is 1 into f of 1, it becomes f of 1 minus f of 1, right? If you apply the limit directly, I'll get f of 1 minus f of 1 divided by 1 minus 1, correct? It takes 0 by 0 form, correct? Applying the limit directly, putting x equal to 1 power n is 1 into f of 1 is f of 1 minus f of 1 divided by 1 minus 1 takes 0 by 0 form. So we'll apply L'Hopital's rule. Differentiate numerator and denominator separately. Apply L'Hopital's rule. Differentiate numerator and denominator separately. What we get? Limit x tends to 1. Differentiating the numerator, correct? F of 1 is constant, f of 1 keep as it is, constant into variable, constant write as it is, differentiate the variable, f of 1 into derivative of x power n is n into x power n minus 1, derivative of f of x is f dash of x, correct, divided by, differentiate the denominator, derivative of x is 1, derivative of 1 is 0, is given to be equal to 44. Apply the limit now, put x equal to 1, what we get? N into f of 1, putting x equal to 1 here, 1 to the power n minus 1 is 1 into n is n, so n into f of 1, I'm getting n into f of 1 minus f dash of 1 is equal to 44, denominator is 1, no need to write. Now find out f of 1 and f dash of 1 from the given function f of x. F of 1 will calculate. F of 1 is got by putting x equal to 1 in this. F of 1 is equal to how much? 1 power 6, that is 1, plus 2 into 1 power 4, that is 2, plus 1 cube, 1, plus 2 into 1, 2, plus 3. This will add up to 1 plus 2, 3, 3 plus 1, 4, 4 plus 2, 6, 6 plus 3, 9. F of 1 is 9, correct? Putting x equal to 1, we get f of 1. Also find f dash of 1. Differentiate the polynomial and then put x equal to 1. First find f dash of x. What is f dash of x? We get derivative of x power 6 is 6 x power 5 plus constant into variable. Derivative of 2x power 4 is 2 into 4x cube. 2 into 4, 8x cube. Correct? Plus derivative of x cube is 3x square. Plus derivative of 2x is 2, derivative of 3 is 0. Now put x equal to 1, f dash of 1. What do you get? 6 into 1 power 5, that is 6. 8 into 1 cube, 8. 3 into 1 square, 3 plus 2. How much you get? 6 plus 8, 14. 14 plus 3, 17 plus 2, 19. F dash of 1 is 19. Substitute the values now. N into, what is f of 1 we got? 9 minus f dash of 1 is 19 is equal to 44. From this we get 9n is equal to 44 plus 19, 63, which gives n is equal to 7. 63 divided by 9 equal to 7. Required value of n is 7. Hope you understand. A simple question asked on 0 by 0, L'Hopital's rule, applying L'Hopital's rule and simplifying and getting the value. Also, you need to find f of 1 from the given polynomial. Also, f dash of x, differentiate the polynomial and then put x equal to 1, you get f dash of 1 and substitute and solve the equation. Simple question, level 1 kind of question this is. Also, the solution is given to here. Okay, answer is 7. Move on to the next one. The value of limit x tends to 0, 2 minus cos x into root of cos 2x whole to the power x plus 2 by x given to equal to e power a. Find the value of a. Question asked on 28th July 2021. You can apply the limit directly. Cos 0 is 1. 2 into 0, 0, cos 0 is 1, root 1 is 1, 1 into 1, 1, this becomes 1 here, 2 minus 1 is 1, the base is approaching 1, as x approaches 0, the base is approaching 1, and the power is approaching what? If you put x equal to 0, 0 plus 2, 2, 2 by 0, 2 by 0 square, 2 by 0 is infinity, correct? So, as x approaches 0, as x is approaching 0, it takes 1 to the power infinity form, correct? 1 to the power infinity form it takes. The base is approaching 1 and the power is approaching infinity. So 1 to the power infinity form, already we've done many problems in the previous video also, correct? 1 to the power infinity form questions were asked in 2020 as well, correct? We know the formula. Limit x tends to e, f of x for g of x is equal to what? E power limit g of x into f of x minus 1. Those are not listen to the last previous video and write the formula again. Limit x tends to e, f of x to the power g of x. If it takes 1 to the power infinity form, what we can write? E power limit x tends to a, g of x into f of x minus 1. This is the formula I'm going to use whenever it takes 1 to the power infinity. As x approaches, see, f of x for g of x takes 1 to the power infinity form, we apply this formula. E power limit g of x into f of x minus 1. So I'll be using that formula now for this. Okay. So that's equal to, I'll write here e power limit x tends to 0. Write the power first. Power into base minus 1, correct? G of x into f of x minus 1. Write the power first. The power is x plus 2 divided by x square into f of x minus 1. 2 minus cos x into root of cos 2x minus 1. 2 minus cos x into root of cos 2x minus 1. Applying this formula, we get like this. And 2 minus 1 is 1. So I can simplify it further. I can write this as e power limit x tends to 0. E power limit x tends to 0. X plus 2 divided by x square is that. Into 1 minus cos x into root of cos 2x. Correct? Because 2 minus 1 is 1. Now we'll consider 1 minus cos x into root of cos 2x by x square separately. I'll find out the limiting value for that. As x approaches 0, find out the limiting value for 1 minus cos x into root of cos 2x by x square. Because that takes 0 by 0 form. Correct? So considering this separately, consider limit x tends to 0. Consider this separately now. Limit x tends to 0. Limit x tends to 0. 1 minus cos x into root of cos 2x divided by x square. This is taking 0 by 0 form. So I can apply L'Hopital's rule and evaluate this. Okay. Putting x equal to 0. Denominator is 0 square 0. Correct. Numerator cos 0 is 1. 2 into 0 0. Cos 0 is 1. Root 1 is 1. 1 into 1 1. 1 minus 1, this takes 0 by 0 form, correct? Takes 0 by 0 form. So we can apply L'Hopital's rule. Differentiate numerator and denominator separately. So this is equal to limit x tends to 0, differentiating the numerator, what we get, derivative of 1 0 minus cos x into derivative of root of cos 2x 1 by 2 root of cos 2x into derivative of cos 2x minus sin 2x into derivative of 2x is 2 plus root of cos 2x into derivative of minus cos x. Derivative of minus cos x is plus sin x. Correct? Whole thing is divided by derivative of x square is 2x. Applying L'Hopital's rule. Differentiating numerator and denominator separately. Okay. Here 2 cancels. 2 cancels. Minus into minus is plus. And I can apply the limit for cos function here. I'll show one more step here. Limit x tends to 0. Limit x tends to 0. What we have? Cos x into sin 2x. Cos x into sin 2x divided by root of cos x. I'll bring it to denominator. Okay. Dividing this by this. Separating the terms. Divide individually. This term is divided by 2x. Even this term is divided by 2x. So in that case, what happens? Root of cos 2x will come to denominator. Root of cos 2x into 2x. Plus, here also separate the terms. Root of cos 2x into sin x divided by 2x. Correct? Applying limit for this. And you know, cos 0 is 1. Here also 2 into 0, 0. Cos 0 is 1. This is approaching 1. Even this is approaching 1. Sine of an angle by same angle is 1. Correct? As x approaches 0, sine 2x by 2x. This also tends to 1. Here sin x by x becomes 1. As x approaches to 0, sin x by x is 1. Here 2 into 0, 0. Cos 0 is 1. This becomes 1. So what is left out is, see, this is 1, 1, 1. So 1 plus, here denominator is 2. So 1 by 2 into 1. 1 by 2. So 1 plus half, I'm getting 3 by 2. Correct? 3 by 2, I'm getting the limiting value for this. So here, what we can do is, I can apply limit for x plus 2 separately and apply limit for 1 minus cos x into root of cos 2x by x square separately. If you apply limit for x plus 2 directly here, this will become 0 plus 2, 2, correct? E power 0 plus 2 is 2. And this part is done separately. 1 minus cos x into root of cos 2x by x square. This by this. Separately we evaluated using L'Hopital's rule because it takes 0 by 0 form. There we got the answer is 3 by 2. So 2 cancels, we get e power 3. And it is given to be equal to e power a. We need to find the value of a. The value of a is equal to 3. Hope you understand. It's a combination of 1 to the power infinity as well as L'Hopital's rule. Okay. Remember this important one. This type of question is asked even in 2024 also. I'll discuss it separately. Somewhat similar to this. I can generalize it also afterwards. Okay, when I work out a question on limits which is asked in 2024, I'll generalize it later. Remember this important. Also, this type of question is found in the Singlish book also. I've seen it. One of the question in the numerical type question or integer type question, it's there in Singlish book. On to the next one, the solution is given. Okay, answer is 3 we got. Next one, limit x tends to 0, alpha x into e power x minus beta log of 1 plus x to the base e plus gamma x square e power minus x by x into sine square x is equal to 10. Where alpha, beta, gamma are real numbers, find alpha plus beta plus gamma. Numerical type question asked on 20th July, 2nd shift 2021. So this, you need to find the values of alpha, beta, gamma. First what we should do is, we'll simplify the denominator. Denominator, use sine theta by theta equal to 1 as theta tends to 0. What we do in the denominator is, you multiply and divide by x square there. Okay, here itself, you multiply and divide by x square, divide by x square, multiply by x square. So that sine square x by x square becomes 1. Correct? As x tends to 0, sine x by x the whole square is 1. So denominator becomes x into x square, x cube. So I shall write in a simplified form directly. Limit x tends to 0. Limit x tends to 0, alpha x e power x minus beta into log of 1 plus x. This question is based on the series expansion. I'll be using the infinite series expansions for e power x, log 1 plus x and e power minus x. Okay. First time the question is asked based on the series expansion so far, the questions we discussed, plus gamma into x square e power minus x divided by denominator is x cube. Denominator is x cube is equal to 10. Correct? E power x is substitute. The series expansion for e power x. And denominator is x cube. No, I'll write the terms up till you get x cube. Higher powers x power 4, x power 5, all those things not required. I shall not write the higher powers up till x cube I need, because I want to evaluate this limit x tends to 0 and the limiting value is given to be equal to 10 already. I'm finding the values of alpha, beta and gamma. Correct? So writing the series expansions for this. Limit x tends to 0, alpha x into e power x. What is e power x? 1 plus x square by 2 factorial plus x cube by 3 factorial. Other terms I won't write because x into x square x cube I got. Correct? Up to infinity. Minus beta into log 1 plus x. What is the series expansion for log 1 plus x? X minus x square by 2 plus x cube by 3 minus x power 4 by 4 etc. up to infinity. Not required. Up till x cube is enough because denominator is x cube. No, that's the reason. Plus gamma into x square. Other terms will become 0. I'll explain how it becomes 0. Because denominator is x cube, I'm writing only terms up till x cube. Because all these are infinite series expansion. Higher powers x power 4, x power 5 etc. will approach to 0. That's why I'm not writing it. Gamma x square into e power minus x. What is the series expansion for e power minus x? 1 minus x plus x square by 2 factorial minus x cube by 3 factorial etc. up to infinity. Close the bracket. Whole thing is divided by x cube. Correct? Is given to be equal to 10. Now collect the terms. We can multiply alpha x inside, alpha x into 1 alpha x. Here I get beta x, here gamma x square. I'll group the terms with x, terms with x square, terms with x cube, group the terms. Okay, so what we get, this implies limit x tends to 0, limit x tends to 0. If you take x common, what do you get? Alpha. Correct? Here minus beta, and next I'll divide by x cube simultaneously. Okay, divided by x cube plus x square you take common. Now collect the terms with x square. Here alpha x into x, alpha x square you get. So coefficient of x square is alpha. Here minus into minus plus, coefficient of x square is beta by 2. Beta by 2. Here gamma x square, coefficient of x square will be gamma here. Correct? Divided by x cube. I'm separating the terms. I'm separating the terms and writing. Next, x cube term I'll collect. X cube. If you collect x cube term, how do you get? Alpha x into x square. 2 factorial is 2. So you get coefficient of x cube as alpha by 2 there. Alpha by 2. Here minus into plus is minus. Coefficient of x cube is beta by 3. Beta by 3. Gamma x square into x, gamma x cube. So I'll get coefficient of x cube as minus gamma. Close the bracket. Divided by x cube. Next, if you write x power 4, no? Terms with x power 4. X power 4 into something. If you want to show one step. X power 4 into something. I'm not interested to fill the bracket. Divided by x cube. Like that it goes on. Etc. up to infinity is given to be equal to 10, right? Hope you understand. Dividing each of the brackets by x cube because denominator is x cube. Whole thing is divided by x cube is there. Correct? Separating the terms. I'm getting like this. Here you see what happens. X power 4 by x cube will become x, no? X is approaching 0, right? 0 into some finite number is 0. Likewise, other terms. X power 5 into something by x cube. X power 5 by x cube will be x square. X square into something. X is approaching 0. From here onwards, all the terms will approach to 0. All the terms will become 0 from here onwards. X power 4 onwards, all the terms will become 0. That's why I'm not writing it, not indicating it also. Higher terms, higher powers. Here you see x by x cube becomes x square. Denominator becomes x square, no? As x tends to 0, denominator is becoming 0. That means limit does not exist. For limit to exist, because limit is already given to be equal to 10, no? That means limit of this expression is going to exist finitely because the 10 is a finite number. So what happens? I insist the condition that alpha minus beta should be 0. Okay? alpha minus beta should be 0. Here also, second term you see, x square is going to cancel. In the denominator, x remains, right? So x is approaching 0. So denominator is becoming 0, means limit does not exist. It becomes a contradiction to the given question, right? So I insist the condition that alpha plus beta by 2 plus gamma also should be 0. I take alpha minus beta 0, so that limit is going to exist, correct? 0 into some number is equal to 0. Here also, this will become 0, correct? So that limit of the function is going to exist. Here x cube is going to cancel, correct? And this becomes constant. If you apply limit also, it will be the same thing, correct? X cube got cancelled here. All these terms onwards it becomes 0. X power 4 by x cube is x. From here it becomes 0 as I told earlier. And this should be equal to 10 because limiting value is given to be equal to 10. So what I get here, I get three conditions here. One is alpha minus beta should be 0. That means alpha is equal to beta I am getting. Second condition I am getting alpha plus beta by 2 plus gamma equal to 0. Alpha plus beta by 2 plus gamma should be equal to 0. And the third condition is alpha by 2 minus beta by 3 minus gamma, that should be equal to 10. Solving these three equations will get the values of alpha, beta, gamma. Then you can find alpha plus beta plus gamma. If you want, I'll show a few steps here. Alpha is equal to beta we got, right? That you can substitute here. Alpha is equal to beta. So this becomes alpha by 2. In place of beta, I'll write alpha. Alpha plus alpha by 2. 3 alpha by 2 plus gamma equal to 0. I'll write here itself. 3 alpha by 2 plus gamma is equal to 0. Correct? That is one equation. Using this in this, use alpha equal to beta in this, what I'll get? Alpha by 2 minus beta and put alpha. So alpha by 2 minus alpha by 3. How much is that? LCM of 2 and 3 will be 6. Correct? So 3 alpha minus 2 alpha. That is alpha by 6. I'll get alpha by 6 minus gamma is equal to 10. Using alpha equal to beta in the second equation and third equation, I'll get the two equations like this. And you can, if you add these two equations, gamma is going to cancel, right? Plus gamma minus gamma is going to cancel. 3 alpha by 2 plus alpha by 6 will be equal to 10. So that will get the value of alpha. I'll write here itself 3 alpha by 2, 3 alpha by 2 plus alpha by 6 plus alpha by 6 is equal to 10. You multiply the entire equation by 6 so that it becomes easy. 3 alpha by 2 into 6, 2 ones are 2 3s are, so it becomes 9 alpha plus alpha is equal to 60. 10 alpha equal to 60. So alpha is equal to 6. Alpha equal to 6. Correct? 10 alpha equal to 60. So alpha is 6. If alpha is 6, beta is also 6 because we got alpha is equal to beta. Correct? Alpha is 6. Beta is also 6. And gamma is how much? Gamma is minus 3 alpha by 2 from this. Gamma is equal to minus 3 alpha divided by 2. Minus 3 by 2 into alpha, how much we got? 6. 2 ones are 2 3s are 3 into 3 9, so minus 9. They asked to find alpha plus beta plus gamma. Alpha 6, beta 6, gamma minus 9. 6 plus 6 12, 12 minus 9, 3 is the answer. Required answer is 3. Hope you understand this. Using infinite series expansions for e power x, log 1 plus x and e power minus x, we got the answer like this. Please make a note of this. Solution is also given to you here. Detailed solution, solving the equations and getting the answer 3. Practice all these problems, important. Another question asked on a series expansion here. You define a plus b plus c equal to how much? Question asked on 16th March, first shift 2021. A into e power x minus b cos x plus c into e power minus x divided by x into sin x is given to be equal to as x tends to 0. What we'll do is in the denominator divide by x, multiply by x. So that sin x by x is 1, correct? This becomes 1. Sin x by x is approaching 1 as x tends to 0. Denominator will be x square. X into x, x square. So what do you get? Limit x tends to 0. Limit x tends to 0. A into e power x minus b into cos x plus c into e power minus x divided by sin x by x is 1. So x is given to be equal to 2. Correct? Denominator is x square. So write the series expansions for e power x, cos x and e power minus x up till terms with x square because denominator is x square. In the previous problem, denominator was x cube. So I wrote the terms up till x cube. Correct? And higher powers, no need to write because it becomes 0. I need to find the values of A, B, C, A plus B plus C. That means I need 3 equations. In the previous question also, we needed to find alpha, beta, gamma. I got 3 equations and got the values of alpha, beta, gamma, correct? So now applying series expansions for e power x, cos x and e power minus x. What do you get? Limit x tends to 0. A into e power x is 1 plus x square divided by 2 factorial plus x cube by 3 factorial, etc. Not required. Only up till x square is enough, as I told, plus etc. Minus b into cos x. What is series expansion for cos x? 1 minus x square divided by 2 factorial plus x power 4 divided by 4 factorial minus etc. up to infinity, plus c into series expansion for e power minus x is 1 minus x plus x square divided by 2 factorial minus etc. up to infinity. Whole thing is divided by x square, correct? Whole thing is divided by x square is given to be equal to 2. Now, as usual, collect the constant term. There are constant terms also here. In the previous question, we didn't have constant term, I think. Now we are having some of the terms are constant here, correct? A into 1 A, B into 1 B minus B plus C. Collect the constant terms in one bracket. Then terms with x square. Collect all the terms, group the terms. What we get? Limit x tends to 0. Limit x tends to 0. A into 1 A minus B plus C. Separate it out, divided by x square. Simultaneously, I am dividing by the denominator x square. Next, you collect the terms with x. X into, what is the coefficient of x? A here from the first bracket. From the second bracket, what is coefficient of x? Coefficient of x does not exist there, correct? X term is not there in the second bracket. In the third bracket, there is x. Coefficient of x is minus c. So minus c divided by x square. Next, in the collecting the terms with x square terms will collect. In the first bracket, coefficient of x square is a by 2, correct? A by 2, because 2 factorial is 2, a into 1 by 2, a by 2. Here, coefficient of x square how much? Minus into minus plus b by 2, correct? Coefficient of x square how much here? C by 2. Minus into minus became plus. Here it is plus c by 2. Close the bracket. Divided by x square. Next, x cube terms I won't write. As I told in the previous question also. X cube term if we write also. X cube into, I am not interested to fill this bracket. Divided by x square plus other terms etc. up to infinity is equal to 2. Correct? Your x cube by x square becomes x. Limit x tends to 0 if you apply. This will become 0. 0 into some finite number is 0. From here onwards all the terms will become 0. All the terms are becoming 0 here. Correct? Now, as x approaches 0, denominator is becoming 0. That means limit does not exist here, correct? So, limit is already given to be equal to 2, no? It's a finite number. For limit to exist finitely, we insist the condition that a minus b plus c is equal to 0, correct? Because a minus b plus c into 1 by x square. 1 by x square is approaching a big number because x is approaching 0, correct? So, quite large number. But this a minus b plus c, if it is 0, 0 into some large number is 0. So that limit of the function is going to exist finitely. We insist the condition that a minus b plus c, that should be equal to 0. Same story for this also, second term. Denominator c, x, 1x will remain there. 1x will cancel here, 1x remains. And that x is approaching 0. So we insist the condition that a minus c is equal to 0. Here x square is going to cancel. It is becoming a constant here. If you apply the limit also, limit of a constant is constant. So this should be equal to 2. That is what we get. Right hand side is 2. That is the limiting value. So the limiting value is dependent on this third term actually. So a by 2 plus b by 2 plus c by 2. That should be equal to 2. And no need to solve this equation actually. The equations, 3 equations we got. No need to solve these 3 equations to find the individual values of a, b, c. Because they asked to find a plus b plus c. I got the answer here itself. See, multiply the entire equation by 2 here. You get the answer. A plus b plus c is equal to how much? We get 4, right? Multiply by 2, entire equation. We get a plus b plus c equal 2 into 2 is 4. So required answer is 4. Simple question. Practice all these things, not difficult, all these things. You need to learn the formulas for series expansions, e power x, e power minus x, sin x, cos x, tan inverse x, sin inverse x, log 1 plus x, all are given. The series expansions are given for all these things. So you need to practice, you need to learn all the formulas, then work out the problems. It becomes easy. Okay. Move on to the next one. Solution is also given to you here. Detailed solution is given to you. Next one. Again, the question asked on series expansion. Limit x tends to 0 exists and it is equal to b. Find the value of a minus 2b. Question asked on 25th of February, second shift, 2021. So, limit x tends to 0 of this expression ax minus of e power 4x minus 1 divided by ax into e power 4x minus 1 exists and it is equal to b. What is given here? Limit x tends to 0. Limit x tends to 0. Ax minus e power 4x minus 1 divided by ax into e power 4x minus 1 is given to be equal to b, a finite number. What we'll do is you divide by 4x here, divide by 4x, multiply by 4x. So that e power 4x minus 1 by 4x becomes 1, correct? This will approach to 1. This will approach to 1 as x tends to 0. Power and denominator is same, no? We know the limit theorem. Limit x tends to 0, e power x minus 1 by x is 1. So this is becoming 1. So what we get now? Limit x tends to 0. What do you get? Ax minus of e power 4x minus 1 divided by denominator is, this is becoming 1, 4a into x square, correct? 4a x square. Because denominator is x square, correct? You write the series expansion for e power 4x up till x square term. Okay, x cube not required. Higher powers of x will become 0 as I told earlier. Write the series expansion for e power 4x. E power x we know. Now I want e power 4x. So replace x by 4x and write the series expansion for that. What do we get? Limit x tends to 0. Limit x tends to 0. Ax minus of e power 4x. Writing the series expansion, what do you get? 1 plus 4x plus 4x the whole square divided by 2 factorial plus 4x the whole cube by 3 factorial. X cube terms not required, etc. Minus 1 is there, write that, minus 1 divided by 4ax square is equal to b. Plus 1 minus 1 cancels. Plus 1 minus 1 will add up to 0. So now I'll collect the terms with x square like that. So plus 1 minus 1 will add up to 0. Now collect the terms with x. Collecting the terms with x. Limit x tends to 0. Limit x tends to 0. What we have? X is common, correct? In the first two, x into, I'll get a minus 4, correct? Writing the terms with x divided by 4ax square. Separate the terms. 4ax square plus x square term you collect. Minus into plus is minus. 4 square is 16. 16 by 2 factorial is 2. 16 by 2 is 8. Correct? 8x square divided by 4x square. So I'm getting minus into plus minus. Minus, what is that? 16 by 2. That is 8. 8x square divided by 4ax square. Divided by 4ax square. Higher terms I'm not going to write. X cube. X cube by x square will become x. That x is becoming 0. Limit x tends to 0. Other terms are 0, all right? Other terms are 0. Correct? Is equal to b. Is given to be equal to b. Now, as here 1x will cancel, denominator will become 4ax. Denominator is becoming 0. That means limit of the function is not going to exist. We insist the condition that a minus 4 equal to 0, so that limit becomes a finite number. We have a minus 4 is equal to 0. A minus 4 is equal to 0 means a is equal to 4. We got the value of a. And here x square is going to cancel. It becomes minus 8 by 4a. Minus 8 by 4a is minus 2 by a. Minus 2 by a is a constant. Limit, if I apply also, it is constant. Limit of a constant is constant. So we get minus 2 by a is equal to b. Correct? So that should be equal to b. Rest all terms are 0. A value already we got. We can substitute the value of a, 4. So minus 2 by 4. So value of b is minus half. A is 4 and B is minus half. Want to find the value of A minus 2B. Therefore, A minus 2B is equal to A we got 4 minus 2 into B values minus half. 2 cancels, correct? 4 minus into minus plus 4 plus 1 is equal to 5. Required answer is 5. Questions asked on series expansion. Simple one. All these things you should take out the problems and work out on your own after understanding it. First learn the formula, understand, then practice. You can improve. Solution is given to you. Answer is 5. Detailed solution is given to you here. Next one. Question number 6. Yeah, from R to R, we have continuous function. Limit x tends to pi by 4. Integration sign is there. If it takes 0 by 0 form, it's a combination of the L'Hopital's rule and Newton-Leibniz formula. Already we've done this type of questions in the previous video also. In the 2020 paper also many questions were asked on Newton-Leibniz formula, 2019 as well. Correct? Limit x tends to pi by 4. Integration sign is there. Limit is there. Integration sign is there. That to a definite integral is given to you. Most of the time I can give guarantee that it's a combination of Newton-Leibniz and L'Hopital's rule. Correct? If you apply the limit directly, what happens? Put x equal to pi by 4. What is given? The question is limit x tends to pi by 4. Limit x tends to pi by 4. What is that? Pi by 4 is some constant given to you here. Integral from 2 to secant square x, correct, into f of x dx divided by x square minus pi square by 16. If you apply the limit directly, what happens? Put x equal to pi by 4 here. Pi by 4 square how much? Pi square by 16. Pi square by 16 minus pi square by 16 is 0. Denominator is becoming 0. What about the numerator? Put x equal to pi by 4. Secant pi by 4 is root 2. Root 2 square is 2, correct? So this is becoming 2. Integral from 2 to 2 means it becomes 0. Correct? Denominator is becoming 0. When you apply the limit x equal to pi by 4. Pi by 4 square is pi square by 16. Pi square by 16 minus pi square by 16 is 0. Denominator is 0. Numerator is also 0. Correct? Secant pi by 4 is root 2. Root 2 square is 2. Integral from 2 to 2 is going to be equal to 0. 0 by 0 form. So we can apply L'Hopital's rule. Apply LH rule. Differentiate numerator and denominator separately. Apply LH rule. In short, I'll write L'Hopital's rule as LH rule. Differentiate the numerator and denominator separately. Correct? Limit x tends to pi by 4. What do you get? D by dx. Pi by 4 is constant. Keep there itself. D by dx of integral from 2 to secant square x f of x dx divided by, differentiate the denominator, d by dx of, what do you get? X square minus pi square divided by 16. When you differentiate a definite integral, I am using the Newton-Leibniz formula. Correct? Integration and differentiation is going to cancel out. Substitute the upper limit, differentiate the upper limit. And substitute the lower limit, differentiate the lower limit. Correct? What we get here? That's equal to, actually I think they should have given f of t dt. I think so, because normally the limits of the integral will have one variable and the integrand will have another variable, but they are given the same variable. Nothing to worry much, still we can do it. This is equal to limit x tends to pi by 4. Limit x tends to pi by 4. Here pi by 4 is constant. Integration and differentiation will cancel out. Substitute the upper limit. What do you get? F of secant square x into derivative of secant square x by chain rule. Derivative of secant square x is 2 secant x into derivative of secant x is secant x tan x minus, substitute the lower limit, differentiate the lower limit, that is going to be 0. F of 2 into derivative of 2 is 0. Correct? Divided by denominator, differentiate, derivative of x square is 2x. And derivative of pi square by 16 is 0 because it's constant. Now we can apply the limit. When you put x equal to pi by 4, secant pi by 4 is root 2. Root 2 square is 2. Correct? This becomes equal to pi by 4 into f of, this becomes how much? Secant pi by 4. Putting x equal to pi by 4. Secant pi by 4 is root 2. Root 2 square is 2 into 2 into secant pi by 4 is root 2. Secant pi by 4 is root 2. Tan pi by 4 is 1. F of 2 into 0, that is 0. Divided by 2 into pi by 4, that is pi by 2. Correct? So much we get. Root 2 into root 2 becomes 2. 2 into 2 is 4 there. So this is equal to pi by 4 into numerator is 4 f of 2 divided by pi by 2. Correct? This pi is going to cancel. 4 will cancel. This 2 will go up. Denominator goes to numerator. Answer is 2 times f of 2. Option C is answer. 2 times f of 2. Hope you understand this. Newton-Leibniz formula. Answer is option C. Question number 7. Alpha, beta are the distinct roots of this quadratic equation. X square plus bx plus c equal to 0. You have to find this. Limit x tends to beta of e power 2 times x square plus bx plus c minus 1 minus 2 times x square plus bx plus c divided by x minus beta the whole square. This is a combination of series expansion and a quadratic equation. Alpha and beta, the distinct roots of this equation, x square plus bx plus c equal to 0. Note that the coefficient of x square is 1 here. Correct? Beauty of this quadratic is coefficient of x square is given to be equal to 1. Since alpha and beta are the roots of this equation, x square plus bx plus c equal to 0, roots of this equation are what? Alpha and beta. We can write the quadratic in the form of x minus alpha into x minus beta. I can write x square plus bx plus c. X square plus bx plus c identically equal to x minus alpha into x minus beta. Also, I can write the relationship between the roots and the coefficient. Alpha plus beta is equal to how much? Minus b by 1. And alpha into beta, product of the roots is c by 1, c. Correct? Minus b by 1, that is minus b. C by 1 is c. So this much information we know about the quadratic equation. Because alpha and beta are the distinct roots, we can write this quadratic in the form of x minus alpha into x minus beta. Also, sum of the roots is minus b by 1 minus coefficient of x by coefficient of x square. Product of the roots is constant term by coefficient of x square, c by 1c. Now, I want to find out this. I need to apply the series expansion because there is an exponential function, no? E power 2 times x square plus bx plus c. I'll apply the series expansion for e power x. Instead of x, I got 2 into x square plus bx plus c. And here also you can see in the terms minus 1 and minus 2 times x square plus bx plus c. Some terms are going to cancel there, correct? So that's equal to e power, that is given expression is limit x tends to beta. Limit x tends to beta. Apply the series expansion for this. E power x is what? 1 plus x square by 2 factorial etc. up to infinity. Denominator is given as x minus beta the whole square. No, that means denominator is a polynomial of degree 2. So write the series expansion for e power x up till x square only. X cube only is not required because that will become 0. Correct? So what is writing the series expansion for exponential function? E power 2 times x square plus bx plus c is equal to what? I can write it as 1 plus x. Instead of x, we got 2 times x square plus bx plus c, correct? Plus x square by 2 factorial. X square means 2 square. 2 square is 4. 4 times x square plus bx plus c divided by x square, no? So square of this, divided by 2 factorial etc. up to infinity. 1 plus x square by 2 factorial plus higher powers of x not written because only up till x square is enough because denominator is a polynomial of degree 2 and rest terms are right as it is minus 1 and minus 2 times x square plus bx plus c. Some terms are going to cancel here, correct? They're of opposite sign, correct? Plus 1 minus 1 will add up to 0 and this will also add up to 0. 2 times x square plus bx plus c minus 2 times x square plus bx plus will add up to 0. Remaining terms are not written and not shown also here, correct? Those terms will be becoming 0. I'll explain that next step. Divided by what we have? X minus beta the whole square. So what is left out? 2 factorial is 2, 4 by 2 is 2. So this is equal to limit x tends to beta. Limit x tends to beta. What we have? 4 by 2 is 2. x square plus bx plus I'll write it as x minus alpha into x minus beta, making use of this because alpha and beta are the distinct roots of that quadratic. X square plus bx plus I'll write it as x minus alpha into x minus beta. So x minus alpha the whole square into x minus beta the whole square because square is there, correct, divided by x minus beta the whole square. Rest other terms are not written here and not shown here. Those terms are becoming 0, correct, because those terms will contain minimum x minus beta and the whole cube will be there. X minus beta the whole cube by x minus beta the whole square become x minus beta into something will be there. Some other terms also there, but x is approaching beta, so x minus beta will approach 0. So whatever terms are didn't write here, all those terms are becoming 0. Now see, x minus beta the whole square is going to cancel and x is approaching beta, so I can substitute 2 times x almost becomes beta, so beta minus alpha the whole square. We know beta minus alpha the whole square is same as alpha minus beta the whole square. That is equal to, what is alpha minus beta the whole square? I can write it as alpha plus beta the whole square minus 4 alpha beta using the basic algebraic identity, correct? A minus b whole square is a plus b whole square minus 4ab, expressing alpha minus beta in terms of alpha plus beta and alpha into beta. Because I know alpha plus beta is minus b and alpha into beta is c, already written here, the information about the quadratic relationship between the roots and the coefficients. Alpha plus beta I can substitute minus b, so 2 times this is minus b the square minus 4 into alpha into beta is c, correct, close the bracket, that's equal to 2 times minus b square is same as b square minus 4c, 2 times b square minus 4c, option C is the answer. Hope you understand this. Solution is given to here, please make a note of this. If you want to take a screenshot of this. Move on to the next one. Question number 8. Limit x tends to infinity, root of x square minus x plus 1 minus ax is equal to b. Find the ordered pair a comma b. Various options are given. Question asked on 27th of August, second shift 2021. X tends to infinity. All the options correct. Is either half or minus half, a plus 1 or minus 1. Or to find the ordered pair a comma b. So because if you apply the limit directly, it takes infinity minus infinity form, correct? If you apply the limit directly, x equal to infinity square minus infinity plus 1, if you simplify, root of that is going to be infinity, because the root of infinity square, you can take infinity minus infinity form I can take. This takes infinity minus infinity, which is an indeterminate form. The 7 indeterminate forms I told already in the synopsis part, correct? So it takes infinity minus infinity, is an indeterminate form. We'll rationalize this. Limit x tends to infinity, rationalize root of x square minus x plus 1 minus ax is it, multiply and divide by the conjugate of this, root of x square minus x plus 1 plus ax divided by the same thing, root of x square minus x plus 1 plus ax is given to be equal to b, multiplying and dividing by the conjugate. And the numerator you can apply the formula a minus b into a plus b. A minus b into a plus b is a square minus b square, correct? Difference of 2 squares. So limit x tends to infinity, we have limit x tends to infinity. Numerator becomes what? Root of x square minus x plus 1 the whole square without root, right? That is x square minus x plus 1 minus ax the whole square, that is a square x square, a square x square, divided by root of what we have, x square minus x plus 1 plus ax is equal to b, correct? X square take common from this. Limit x tends to infinity, x square common in the numerator, connecting the terms with x square, you get 1 minus a square minus x plus 1 divided by what we have, denominator, root of x square minus x plus 1 plus ax is equal to b. Correct? And because limit is a finite number, look at the degree of the denominator. Denominator is degree is 1, I can tell, because when you take the square root of x square, it becomes x. Root of x square is strictly speaking mod x, but if x is positive, x approaches to a positive number, I can tell mod x will become x. So degree of denominator is x. And degree of numerator also should be, degree of denominator is 1, correct? The highest power of x is 1, correct? Here it is 1. Here also if you take the square root, I can tell the highest power of x is 1 there, correct? So I can tell that degree is somewhat 1. It's not actually polynomial here because it involves a root here, correct? So I want to make the degree of numerator denominator same here. So that limit is going to exist. If degree of numerator is bigger than degree of denominator, then the limit is going to become infinity as x approaches to infinity. So we insist the condition that 1 minus a square should be equal to 0. We insist the condition that 1 minus a square equal to 0 for limit to exist. Otherwise limit is not going to exist because here x square is there, no? X square approaches to infinity much faster than x approaching to infinity, right? So denominator is only x, the highest power of x 1 because you take the root of there, correct? So this approaches infinity. This also approach numerator and denominator both approaches to infinity, but numerator approaches to infinity much faster than denominator, so it becomes infinity ratio. So limit becomes infinite in that case. But b is given to be all finite numbers. B is either plus half or minus half. You see the options. So I insist the condition that 1 minus a square should be equal to 0. 1 minus a square equal to 0. So I get a square is equal to 1. A square is 1 means a equal to plus or minus 1. Either plus 1 or minus 1. Putting a square equal to 1, this part is gone, right? So this part is no more exists. This will become 0. So what is left out is limit x tends to infinity. Limit x tends to infinity. What we have? Minus x plus 1. Correct? That is 1 minus x I can tell. I can take x common there. X if we take common, I get minus 1 plus 1 by x. Correct? And denominator you take x common. In fact, you take a root x square common inside this root. X square you take common. X square if you take out, what remains? 1 minus 1 by x plus 1 by x square, correct? Plus ax. Root of x square is mod x. Mod x, I'll write x because x is positive here. Limit x tends to infinity. I'll take x common from the denominator. Numerator already x is taken out. Minus 1 plus 1 by x divided by x is common from the denominator. What is left? Root of 1 minus 1 by x plus 1 by x square plus a, correct, is equal to b. X cancels. As x approaches infinity, 1 by x will approach 0. 1 by x will become 0. 1 by x square will become 0. Correct? So what is left out after applying the limit? Minus 1 plus 0. Minus 1 by root of 1 minus 0 plus 0. That is root 1 is 1 plus a is equal to b. I'm getting like this. After I apply the limit and simplify, I got like this. If a is equal to 1, what is the value of b? You can calculate. If a is 1, if a is equal to 1, b is equal to what I get? Minus 1 divided by 1 plus putting a equal to 1. So I'm getting b as minus half. And if you put a equal to minus 1 plus 1 becomes 0. B does not exist. So a equal to minus 1 is not possible. A equal to minus 1, b not defined. Correct? B is not defined. So it's not possible. In this case is not possible because the denominator has become 1 minus 1, 0. Minus 1 by 0, not defined. So this case is not possible. Take this case. A equal to 1, b equal to minus half is the answer. Ordered pair is 1 comma minus half. A comma b is ordered pair. A comma b is 1 comma minus half. A is 1, b is minus half. Hope you understand this. Taking the indeterminate form, infinity minus infinity. Rationalize it. Multiply numerator to numerator, use the formula a minus b into a plus b, a square minus b square, and simplify it. Collect the terms with x square, and we insist the condition that coefficient of x square should become 0, otherwise limit is not going to exist finitely. So we take 1 minus a square equal to 0. A square is 1, a is either plus 1 or minus 1, two cases, and for a equal to 1, b is minus half, we get after simplifying it, and a equal to minus 1, b is not defined. Okay. Question asked on 27th of August, second shift, 2021. Solution is also given to you here. Detailed solution is given to you. Please make a note of it. Next one, move on to the question number 9. Limit x tends to 0. Sine square of pi cos power 4x divided by x power 4 is equal to how much? Question asked on 31st of August, first shift, 2021. Limit x tends to 0. Limit x tends to 0. Sine square of pi into cos power 4x divided by x power 4. Here, if you look at the limit x tends to 0, if I apply, denominator is becoming 0, correct? 0 power 4 is 0. And numerator, apply limit here. Cos 0 is 1. 1 power 4 is 1. 1 into pi is pi. Sin pi is 0. Takes 0 by 0 form. Takes 0 by 0 form. But applying L'Hopital's rule is not so helpful here because it takes more time. Because if you differentiate x power 4, it becomes 4x cubed. Again, it may be in the 0 by 0 form. Correct? At one stretch, you may not get the answer. If you apply L'Hopital's rule, again and again, you should apply L'Hopital's rule to remove that indeterminate form. Our main aim is to remove the indeterminate form, right? So, I will not apply L'Hopital's rule here because you may not get the answer in 1 or 2 steps if you apply L'Hopital's rule. After differentiating numerator and denominator separately, if you apply L'Hopital's rule, again it takes 0 by 0 form. It might take 0 by 0 form because the denominator is x power 4, no? That's why I'll avoid applying the L'Hopital's rule. And second time, if you differentiate this, it becomes complicated. Chain rule need to apply. First time only I differentiate by using chain rule, correct? So second time also you have to apply product rule, chain rule, all those things. Becomes the expression in the numerator becomes very complicated. You can try by applying L'Hopital's rule, but I'll avoid using the L'Hopital's rule and simplify by another method. I'll use cos power 4x as cos square and cos square is 1 minus sine square. We know the familiar trigonometric identity. I'll be using that. Cos power 4x, right? Cos square x the whole square. Okay? Cos power 4x. I'll show the steps here if you want. Cos power 4x, you write it as cos square x the whole square. Correct? Cos square is cos power 4. And you know cos square x is 1 minus sine square x. 1 minus sine square x the whole square. Writing like this for cos power 4x. Substitute here, okay? And you can expand it also. 1 minus sine square x, so we'll expand it. What is the expansion of this? A minus b the whole square. A square plus b square minus 2ab. Correct? Expanding it. 2 into sine square x into 1. I'll be using this. So what we get? Limit x tends to 0. Limit x tends to 0. Sine square of pi into, writing cos power 4x as 1 plus sine power 4x minus 2 sine square x divided by x power 4. Hope you understand this. Multiply now inside. Pi into 1 pi. Correct? Pi into this. Multiply. Open the bracket here. Limit x tends to 0. Our main aim is to remove the indeterminate form. Remember that. Sine square of pi into 1 pi. Pi plus pi into sine power 4x minus 2 sine square x. This takes the form sine square of pi plus theta, right? This takes which form? Sine square of pi plus this entire thing you take it as theta. This pi into sine power 4 minus 2 sine square x is, this entire thing is theta. Sine of pi plus theta is minus sine theta, correct? Sine of pi plus theta, third quadrant. Pi plus theta is third quadrant. Third quadrant sine function is negative. Correct? 180. Pi radians is 180. 180 means same function. So sine square of pi plus theta is minus sine theta the whole square. Minus sine theta the whole square is same as sine square theta. Correct? Sine square of pi plus theta is sine square theta. I'm using this. This entire thing is theta. Correct? So this simplifies to what? Limit x tends to 0. Limit x tends to 0. Sine square of pi plus theta is sine square theta. My theta is this. Pi into sine power 4x minus 2 sine square x divided by x power 4. Look at this angle here. This angle is tending to 0, no? This angle is tending to 0. Pi into sine power 4x minus 2 sine square x. As x approaches 0, sine 0 is 0, sine 0 0, this angle is becoming 0, 0 into pi 0, correct? But this angle was not becoming 0 here, correct? Don't use this method. Some students will do like this. See, I'll show the wrong steps also here. Some students will try doing this method. Sine square of pi into cos power 4x is there, correct? Then divide by pi into cos power 4x and multiply by pi into cos power 4x divided by x power 4 was there, correct? Whether this angle is approaching 0, pi into cos power 4x. As x approaches 0, cos 0 is 1, 1 power 4 is 1, 1 into pi is pi. This angle is tending to pi, no? Correct? This angle is not becoming 0. So we can't write sine of an angle by same angle is 1. We can't write. Of course, I need to put a square here. I need to put a square, correct? Which is sine square is a sine square theta by theta square. This is not becoming 1. This becoming 1 is false. Okay? Don't do this. Warning for you. Don't do this method. It's wrong. Because this angle is not approaching 0. Correct? They can't do that. Why did all these things? So much of simplification I did. Correct? What was the purpose of doing this much of simplification? Because now you see this angle is becoming 0, right? This angle is becoming 0. Whereas this angle is not becoming 0. As x approaches 0, pi into cos power 4x, does it tend to 0? It tends to pi, right? Cos 0 is 1. 1 power 4 is 1. 1 into pi, pi. Do have a theorem like limit x tends to 0, sine x, limit x tends to pi, sine x by x is 1. We don't have, right? X tends to 0, sine x by x is 1. The angle is tending to 0 only. Correct? Sine x by x is 1. Sine of an angle by same angle is 1, provided that angle is approaching 0. Here this happens. See, this angle is approaching 0. As x approaches to 0, what is this? We have pi into sine power 4x minus 2 sine square x. Pi into sine power 4x minus 2 sine square x. This angle is approaching 0, right? Because sine 0, 0. Sine 0, 0. 0 minus 2 into 0, 0. 0 into pi, 0. This angle is approaching 0. Whereas this angle is not approaching 0. Understood the difference? Don't do this. It's absolutely wrong. Don't do that. Now, hope you understood this important step. Now, what I'll do is multiply and divide by pi into sine power 4x minus 2 sine square x. Okay? All these things you need to practice more and more. You can do it within 1 or 1.5 minutes. If you are familiar with all the formulas and concepts, definitely you can do it. But a lot of practice is required, all these things. Okay? So, I can rub this part. I think it's not required. Shown here. So this part, I'll continue here. Limit x tends to 0, what I'm doing, multiply and divide by pi into sine power 4x minus 2 sine square x. Limit x tends to 0. What we have? Sine square of pi into sine power 4x minus 2 sine square x divided by square of this angle, because sine square theta by theta square should be there. So this becomes pi square into sine power 4x minus 2 sine square x the whole square. Correct? Multiply and divide by the same thing. So multiply by pi square into sine power 4x minus 2 sine square x the whole square divided by x power 4 was there. Correct? X power 4. Correct? So this part is becoming 1. Sine square theta by theta square is approaching 1. Sine square of an angle by square of that angle. Correct? Sine square theta by theta square. Whatever angle is present, square of that is present in the denominator. I multiply and divide by the square of that angle. So this part is approaching 1. So what is left out now? Limit x tends to 0. Limit x tends to 0. What we have? Pi square into, here you can take sine square x common, no? Sine square becomes sine power 4x. So what is left inside the bracket now? sine square x minus 2 the whole square divided by x power 4. Now this part will become 1. Sine of an angle by same angle is 1. Sine power 4x by x power 4 is sine x by x whole power 4. Sine x by x is approaching 1 as x tends to 0. So what is left is pi square into 1 into. Now apply limit for this. Sine 0 is 0. 0 square is 0. 0 minus 2. 0 minus 2 is minus 2. Minus 2 square is 4. So answer is 4 pi square. Option D. Hope you understand this. Very nice question asked on limits involving a trigonometric function. Simply cos power 4x as cos square square because powers gets multiplied. 2 into 2 is 4. Cos square x is 1 minus sine square x because cos square plus sine square is 1. From there we get and a minus b whole square formula. A square plus b square minus 2ab. And substituting for cos power 4x like this. Multiply pi into 1 pi into this. And using sine square of pi plus this entire thing is theta. Sine square of pi plus theta is same as sine square theta. Multiply and divide by square of this angle. Shown here. Multiply and divide. Okay, square is there, whole square is there. Simplified and get the answer. 4 pi square is the answer. Solution is given. If you want to note down this, 4 pi square is the answer. In detail, the solution is given. Next one, question number 10. Alpha and beta are given like this. Are the roots of the equation ax square plus bx minus 4 equal to 0. Find the ordered pair a comma b. Question asked on 31st August, second shift. I think same type of question was asked in the earlier shift also. I think one of the earlier question paper. Tan cube x minus tan x by cos of x plus pi by 4. I think in 2019 or 20 we saw this type of question. Very simple one. This takes 0 by 0 form. Applying limit directly. Tan pi by 4 is 1. 1 cube is 1. 1 minus 1 0. Denominator is pi by 4 plus pi by 4 pi by 2. Cos pi by 2 0. 0 by 0 form. I can apply L'Hopital's rule. This takes 1 to the power infinity. Cos 0 is 1. The base is approaching 1 and the power is approaching infinity. Takes 1 to the power infinity form. Evaluate it. For alpha, I'll apply L'Hopital's rule. Okay. Alpha is limit x tends to pi by 4. Apply L'Hopital's rule. Differentiate the numerator and denominator separately. Derivative of tan cube x is what? 3 tan square x into derivative of tan x is secant square x minus derivative of tan x is secant square x. Correct? Divided by derivative of cos is minus sine of x plus pi by 4 into derivative of x plus pi by 4 is 1. Now we can apply the limit. X equal to pi by 4. 3 into tan pi by 4 is 1 square. Secant pi by 4 is root 2 square minus root 2 square. Correct? Divided by putting x equal to pi by 4. Pi by 4 plus pi by 4 is pi by 2. Sin pi by 2 is 1. So I get minus 1. Root 2 square is 2. 2 into 3 6. 6 minus 2 divided by minus 1. 4 by minus 1 minus 4. Alpha we got. Beta is taking 1 to the power infinity form. So beta is e power limit x tends to 0 g of x into f of x minus 1. G of x is the power, that is cot x into f of x minus 1 cos x minus 1. Cot you write 1 by tan, so this becomes e power limit x tends to 0 cos x minus 1. I can write minus of 1 minus cos x. Correct? Cot is 1 by tan divided by tan x. Here you divide by x and multiply by x. Tan x by x is 1 as x tends to 0. What you get is e power limit x tends to 0. What you get? Minus of 1 minus cos x divided by x, because tan x by x is approaching 1 as x tends to 0, and this is a very familiar, we know, limit x tends to 0, 1 minus cos x by x is 0, already given earlier. Otherwise we apply L'Hopital's rule for this, because it takes 0 by 0 form. Correct? Cos 0 is 1, 1 minus 1 0, 0 by 0. If you apply L'Hopital's rule, you can get the answer. Derivative of 1 is 0, derivative of minus cos x is plus sin x, derivative of x 1, this becomes sin x, sin 0 0, e power 0 is same as e power minus 0, answer is 1. E power minus 0 same as e power 0. You can apply L'Hopital's rule for this. Differentiate numerator and denominator separately if you forget the value. I told to remember this value, limit x tends to 0, 1 minus cos x by x is 0. It's a very standard one. And limit x tends to 0, 1 minus cos x by x square is half. Okay, so beta is 1, alpha is minus 4. If alpha and beta, if we got, we can form the quadratic equation. The quadratic equation with roots alpha and beta is given by what? The quadratic equation is x square minus alpha plus beta into x plus alpha into beta equal to 0, right? The quadratic equation we have x square minus alpha plus beta. Alpha is minus 4 and beta is 1 into x. Correct? Alpha is minus 4, beta is 1 equal to 0. I am getting the quadratic equation like this. Minus 4 plus 1 is minus 3. Minus of minus 3 plus 3. I'll write here. This is x square. Correct? Plus 3x minus 4 equal to 0. Compare this equation with ax square plus bx minus 4 equal to 0. Comparing with ax square plus bx minus 4 equal to 0. Comparing, we get a is equal to 1 and b is equal to 3. So ordered a comma b is 1 comma 3, option C. This takes 0 by 0, alpha is taking 0 by 0 form, apply L'Hopital's rule. Beta is taking 1 to the power infinity, apply the relevant formula, get the answer. Alpha and beta, if you know, you can form the quadratic equation with alpha and beta as the roots, x square minus sum of the roots into x plus product of the roots equal to 0. Then you get the equation, compare with this, ax square plus bx minus 4 equal to 0. So a equal to 1 and b equal to 3. Ordered pair a comma b is 1 comma 3, option C. Question number 10 we completed. Solution is given to here. Next, move on to the question number 11. Value of limit x tends to 0, x by 8th root of 1 minus sin x minus 8th root of 1 plus sin x is equal to, question asked on 27th of July, second shift 2021. If you apply the limit directly, numerator becomes 0, denominator sin 0 0, 1 minus 0 is 1, 8th root of 1 is 1. Here sin 0 0, 1 plus 0 is 1, 8th root of 1 is 1, 1 minus 1 0, 0 by 0 form. If I apply L'Hopital's rule, it's not so easy. We got 8th root and all. So I'll avoid applying L'Hopital's rule and rationalize this. Instead of applying L'Hopital's rule, we'll rationalize, multiply and divide with the conjugate of the denominator. Takes 0 by 0 form, limit x tends to 0. What we have? X into, I'll multiply by 8th root of 1 minus sin x plus 8th root of 1 plus sin x divided by 8th root of 1 minus sin x minus 8th root of 1 plus sin x. 8th root of 1 minus sin x plus 8th root of 1 plus sin x. Correct? In the denominator, we can use a minus b into a plus b. A square minus b square, the difference of 2 square. This will become what? 8th root of 1 minus sin x square minus 8th root of 1 plus sin x square. If you want to show the steps here, what is 8th root of 1 minus sin x the square? 8th root of 1 minus sin x the whole square will be what? 8th root means the power is 1 by 8, correct? So what we get is 1 minus sin x to the power 1 by 8 d square. Correct? This will be what? 1 minus sin x to the power 1 by 8 into 2. That is 2 by 8. 2 by 8 is 1 by 4. The power becomes 1 by 4, right? So it becomes 4th root. If you multiply these two, the denominator will be 8th root of 1 minus sin x square will be 4th root of 1 minus sin x. Similarly, 8th root of 1 plus sin x square will be 4th root of 1 plus sin x. 8th root means the power is 1 by 8. 1 by 8, the power gets multiplied. When you square, no? The 1 by 8 into 2 becomes 2 by 8. 2 by 8 is 1 by 4. 1 by, the power is 1 by 4 means it becomes 4th root. This is 4th root. 4th root of 1 minus sin x. 4th root of 1 minus sin x. Understood? A minus b into a plus b, a square minus b square. So this is equal to limit x tends to 0. Limit x tends to 0. X into what we have? 8th root of 1 minus sin x. 8th root of 1 minus sin x plus 8th root of 1 plus sin x. Correct? Denominator will become what? When you multiply these two, a minus b into a plus b, a square minus b square becomes 4th root of 1 minus sin x. 4th root of 1 minus sin x minus 4th root of 1 plus sin x. Still it is in the 0 by 0 form if you apply the limit. Again I'll rationalize the denominator. Multiply and divide by 4th root of 1 minus sin x plus 4th root of 1 plus sin x. Denominator is multiplying this 4th root of 1 minus sin x plus 4th root of 1 plus sin x. Denominator is a minus b into a plus b, a square minus b square. Again, 4th root if you square, now it becomes square root. 4th root means the power is 1 by 4. If you square it, the power becomes 1 by 2. 1 by 2 means square root. Multiplying these two, it becomes square root of 1 minus sin x minus square root of 1 plus sin x. Again, you rationalize that also. To 0, what we have? X into 8th root of 1 minus sin x, correct, plus 8th root of 1 plus sin x, close this bracket. Here 4th root of 1 minus sin x plus 4th root of 1 plus sin x. Another bracket will be root of 1 minus sin x, correct, plus root of 1 plus sin x, because denominator will be what? Square root of 1 minus sin x into root of 1, multiplying and dividing by 4th root. This will become what? Root of 1 minus sin x minus root of 1 plus sin x. Directly I wrote one step, skipping the step, and I wrote directly. So this also had to multiply by root of 1 minus sin x plus root of 1 plus sin x. One step I avoided. And here again, if you multiply a minus b into a plus b, it becomes a square minus b square. Root 1 minus sin x square is 1 minus sin x. Root 1 plus sin x square is 1 plus sin x. So what we'll get here? I'll write here. And you can apply limit for these terms. Like x you keep as it is. Apply limit for this bracket, and this bracket. Okay. So when you apply limit, no, sin 0 is 0. 1 minus 0 is 1. 8th root of 1 is 1 only. Same story here. 1 plus sin 0 is 0. 1 plus 0 is 1. 8th root of 1 is 1. This is approaching 1. This is approaching 1. Even this is approaching 1. Correct? Sin 0 0. 1 minus 0 is 1. 4th root of 1. This also becomes 1. This also becomes 1. This also becomes 1. 1 plus 1 becomes 2. This bracket is 2. This bracket also 1 plus 1 2. This bracket also 1 plus 1 2. 2 into 2 into 2. What I am getting is limit x tends to 0. Limit x tends to 0, x into, this is 2 into 2 into 2, correct? If you want to write 2 into 2 into 2, because 1 plus 1 2 everywhere there, divided by denominator a minus b into a plus b, a square minus b square, 1 minus sin x minus 1 plus sin x, 1 minus sin x minus of 1 plus sin x, plus 1 minus 1 will cancel, correct? 1 minus 1 add up to 0, minus sin x minus 2 sin x. So what I'm getting is limit x tends to 0. What we have? 8 into x divided by minus 2 sin x. And you know, sin x by x is 1 as x tends to 0. So x by sin x also becomes 1. X by sin x is approaching 1. Correct? 8 by minus 2. Answer is minus 4. Minus 4 is answer. Option E. Please make a note of this. Simple question, not a difficult one. Okay. To rationalize again and again and again until you get the 0 by 0 form is removed. Solution is also given to you. Answer is minus 4. Detailed solution is given to you. Please make a note of this. Twelfth one, the value of limit x tends to 0 plus cos inverse of x minus square bracket x square, that is greatest integer function is given, sin inverse of x minus greatest integer value of x square divided by x minus x cube. 0 plus means right hand limit is asked at x equal to 0. We know the technique of evaluating this. X tends to 0 plus means slightly greater than 0. Value of x is slightly greater than 0. So put x equal to 0 plus h, where h is a small positive quantity. Because it involves the greatest integer function, the technique of simplifying this already. Put x equal to 0 plus h. Because x tends to 0 plus, slightly greater than 0. 0 plus a small positive quantity, where h tends to 0. where h tends to 0 and 0 plus, a small positive quantity, indication of a small positive quantity, I write directly h tends to 0. So instead of x tends to 0 plus, I write h tends to 0. H tends to 0. Whatever expression is given, right? Cos inverse of x minus, in place of x I am putting 0 plus h. 0 plus h is h, no? 0 plus h is h. Wherever there is x, you write 0 plus h. 0 plus h is h. So cos inverse of h minus integral value of h square into sine inverse of h minus integral value of h square, correct, divided by h minus h cube, correct. X equal to 0 plus h, where h tends to 0. So instead of writing x tends to 0 plus, you write h tends to 0 and replace x by h. H is a small positive quantity here. Okay, so take h equal to 0.1. Integral value of 0.1 is 0. We know that as h tends to 0, 0 means 0 plus, integral value of h is equal to 0. Correct? Integral value of say 0.1, integral value is 0. This will become 0, this will become 0. This is approaching 0. Not approaching 0, it's exactly 0 there. 0, correct? This is equal to what? Limit h tends to 0. What we have? First to evaluate the greatest integer function. Whenever such greatest integer function or modulus function is given to you, h minus 0 is h into sine inverse of h minus 0 is h, correct? Denominator, I can take h common, becomes 1 minus h square. I can write this as cos inverse h by 1 minus h square. Limit h tends to 0, limit h tends to 0, cos inverse h divided by 1 minus h square into limit h tends to 0, limit of the product is product of the limits we know, sine inverse h divided by h, correct? So now if you apply limit for this, limit apply for the first term and second term, and limit h tends to 0, sine inverse h by h is 1, we know, and for this if you apply limit cos inverse of 0, that is pi by 2, divided by 1 minus 0, pi by 2 by 1 minus 0 into 1, answer is pi by 2. Limit h tends to 0, sine inverse h by h is 1, we know this, limits of trigonometry function are given, sine theta by theta is 1 as theta tends to 0, even h tends to 0, sine inverse of h by h is 1, already proved in the synopsis part, the proof of this is given, okay, refer to the synopsis, and h tends to 0, pi by 2, 1 minus 0, that is 1. So pi by 2 it comes, pi by 2 is answer. Simple question, learn how to evaluate the greatest integer function, and also whenever greatest integer function or fractional part function is given, this technique we are using. 0 plus means slightly greater than 0. So put x equal to 0 plus h, where h is a small positive quantity. Suppose I ask x tends to 1 minus, in that case you put x equal to 1 minus h, where h is a small positive quantity. Hope I understand this. Suppose I ask x tends to 10 plus. 10 plus if I ask, then you put x equal to 10 plus h, where h is a small positive quantity. Suppose I ask limit x tends to 7 minus. 7 minus means slightly less than 7. So put x equal to 7 minus h, where h is a small positive quantity. Hope you understand the idea of limits. Move on to the next one. The solution is also given to you. If you want, you can note down this. If you want to take a screenshot of this, detailed solution is given to you. Move on to the next one. Question number 13. The value of the limit theta tends to 0, tan of pi cos square theta divided by sine of 2 pi sine square theta is equal to how much? Look at the numerator and denominator, correct? If you apply limit directly, no, theta equal to 0, cos 0 is 1, correct? Cos 0 is 1, 1 into pi is pi, tan pi is 0. Denominator, put theta equal to 0, sine 0, 0, 0 square 0, 0 into 2 pi 0, sine 0, 0. It takes 0 by 0 form. You can try by L'Hopital's rule, but I'll avoid using the L'Hopital's rule because it may become extremely lengthy. So I'll use the trigonometric identities and trigonometric limits. Okay, and note down the important thing here. Denominator, no, this angle is tending to 0, but this angle is not tending to 0. Important observation is, as theta tends to 0, numerator, what is the angle? Pi into cos square theta. pi into cos square theta tends to what? As theta is approaching 0, cos 0 is 1, 1 square 1, 1 into pi is pi, correct? It is not approaching 0. The numerator angle is not approaching 0. Whereas denominator angle, see what happens? As theta is approaching 0, what about the denominator angle? 2 pi into sine square theta. Sine 0, 0, 0 square 0, 0 into 2 pi is 0. This is approaching 0, correct? So for denominator, I can use the theorem, limit theta tends to 0, sine theta by theta equal to 1. I can use this. Limit theta tends to 0, sine of an angle by same angle is equal to 1. For denominator, I can use. Whereas for numerator, I can't use tan theta by theta 1 as theta tends to 0 because this angle is not approaching 0. So I need to simplify this. I need to modify this. In the earlier one question also we didn't know same type of simplification. That angle was not approaching 0, correct? We could simplify the trigonometric formulas and somehow we got that angle was approaching 0 after simplification. So numerator I need to simplify using trigonometric formula. For denominator I can use this theorem. Limit theta tends to 0, sine of an angle by same angle is 1. You can for denominator multiply and divide by 2 pi sine square theta so that we can use that theorem and get 1 as answer. For denominator we can use that theorem. Limit theta tends to 0. For numerator, what I'll do is tan of pi into cos square theta, I'll write 1 minus sine square theta. Familiar trigonometric identity. Correct? Denominator, sine of what we have? 2 pi sine square theta. Correct? Multiply and divide by 2 pi. Multiply and divide by 2 pi sine square theta. Correct? Multiply and divide by 2 pi sine square theta. So that sine of an angle by same angle is 1 because this angle is approaching 0. As theta approaches to 0, 2 pi sine square theta is approaching 0. So that becomes 1. Sine of an angle by same angle is 1. What is rounded off is 1. So what is left in the denominator is 2 pi sine square theta. And here you multiply, open the bracket, pi into 1 pi, pi minus pi sine square theta. Correct? Theta tends to 0. What we have? Tan of 1 pi minus pi sine square theta, correct? Divided by 2 pi sine square theta. This takes tan of pi minus theta. What is tan of pi minus theta? Minus tan theta, no? I'm using this. Tan of pi minus theta is equal to minus tan theta. Pi minus theta is a second quadrant angle. Second quadrant tan function is negative. So minus tan theta. This entire thing is theta. Correct? So that will simplify to what? Limit theta tends to 0. Tan of pi minus theta is minus tan theta. Minus tan of pi sine square theta. Divided by 2 pi sine square theta. Now the angle is what? Pi sine square theta. As theta is approaching 0, pi sine square theta is approaching 0, no? Because sine 0 is 0, correct? Sine 0 is 0, 0 square is 0, 0 into pi is 0. This approaches to 0. This angle is tending to 0. Tan of an angle is 1. This becomes 1. So answer is minus 1 by 2. Required answer is minus half. Option B. Trigonometric concepts are used here. Important thing is these two are noted here. Numerator angle is not approaching 0. Denominator angle is approaching 0. So here I could multiply and divide by 2 pi sine square theta. Whereas in the numerator I am using cos square theta as 1 minus sine square theta. Multiply inside, pi into 1 is pi. Pi into minus sine square theta minus pi sine square theta. Then use a tan pi minus theta minus tan theta. Okay. Simplify like this and get the answer. Answer is minus half. Option B. Detailed solution is given to you. Answer is option B. Move on to the next one. Question number 14. Value of limit n tends to infinity. Here, square bracket denotes the greatest individual function. Greatest individual value of r plus greatest individual value of 2r, etc. Greatest individual value of nr divided by n square. This is how much? Question asked on 17th of March, second shift, 2021. So greatest individual function is involved here. We are not able to evaluate this directly because there is greatest individual function here, correct? So not so easy to evaluate. when you're not able to evaluate a given limit by known methods, it may be 1 to the power infinity or infinity minus infinity or 0 by 0. Various methods are there. Series expansions, correct? L'Hopital's rule, Newton-Leibniz rule, various methods we learned. This problem is based on the sandwich theorem. So far the question was not asked until this year, correct? 2021, the first time the question was asked in sandwich theorem. If we compare the papers of 2019, 20 and 21, 19 and 20, no questions were based on the sandwich theorem. Now I'm going to use on sandwich theorem. We must know about the property of the greatest integer function. Greatest integer value of r is there, no? It is always less than or equal to r. It is always less than or equal to r, and it is greater than r minus 1. If you want, you can verify. You take a number and verify it yourself. If you want to give an example, suppose r is integer, no? What is greatest integer value of 6? Greatest integer value of 6 is 6 only. Suppose you take greatest integer value of 6.2. Greatest value of 6.2 is how much? 6. So, the greatest integer value of 6.2 is 6, no? 6 is less than or equal to 6.2. R was 6.2, no? 6.2. And it is greater than 6.2 minus 1, that is 5.2. Correct? Satisfies, no? This condition is satisfied by taking an example. If you take integer, it will be equal to this only, and definitely it is greater than 1 less, correct? Yeah, of course 6 is greater than 6 minus 1, correct? Even for integer and for non-integer, this condition is satisfied. So a property of greatest integer function, learn this. Greatest integer value of r is always less than or equal to r, and it is greater than r minus 1. I am shown by an example also. If you take greatest integer value of 6.2, it is equal to 6. And that 6 is the answer you got, no? For greatest integer value. 6 is less than or equal to 6.2. Of course, 6 is less than 6.2 and it is greater than 6.2 minus 1, 5.2. Correct? This equation is satisfied for non-integer as well as for integer also it is satisfied because 6 is less than or equal to 6 and 6 is greater than 5. 6 minus 1, 5. Correct? So, for integral value, if you want to write 6 is less than or equal to 6 and it is greater than 5. This is for integral value and this is for non-integral value. Your equality is satisfied, your inequality is satisfied. And similarly, I can write for this greatest integer value of 2r. It is less than or equal to 2r and it is greater than 2r minus 1. Like this, you go on, continue. I'll get greatest integer value of nr. Greatest integer value of nr is less than or equal to nr, but it is greater than nr minus 1. Add all these n inequations because I need to find the sum of this, correct? Greatest value of r plus greatest integer value of 2r, etc. Greatest integer value of nr. Add all the n inequations. What I'll get? R minus 1 plus 2r minus 1 plus 3r minus 1. Like this it goes on. What we have? nr minus 1 is less than what we have, integral value of r plus integral value of 2r plus etc. Continue like this, integral value of nr, correct, is less than or equal to, add all those things, r plus 2r plus 3r etc. nr, correct. Is less than or equal to what we have, r plus 2r plus etc. nr. Now what I am going to do is I will divide this entire inequation by n square because I am constructing this. I am sandwiching this expression between another two terms. You know, sandwich theorem. G of x is sandwiched between f of x and h of x. When you are not able to evaluate the limit of this by known methods, we are sandwiching this between the other two functions so that you know to evaluate those two. Correct? The one expression which is given to you, you're not able to evaluate the limit of that expression by known methods. We are sandwiching this between the other two functions so that you know the limiting value of those two functions, and limiting value of those two are equal to some number, same number, and the limit of the middle one is also equal to that number itself. That is the idea of sandwich theorem. So I'm sandwiching this between this and this. So I'm constructing this meanwhile. So divide the entire inequation by n square. You divide by n square here, okay? Divide by n square, divide by n square, divide by n square. Okay, and you can collect the terms now here. Minus 1 is present in how many brackets? There are n brackets, r, 2r, 3r, etc. nr. There are n brackets. Each bracket contains minus 1. Minus 1 is added how many times? N times. So it becomes minus n there. And r I can take common there. R if you take common, 1 plus 2 plus etc. n I'm going to get. So r into 1 plus 2 plus 3 plus etc. n. I'm separating the terms. Divided by n square, I'll write. Okay. Minus 1 is added how many times? N times. So it becomes minus 1, minus 1, minus 1, n times becomes minus n. Minus n divided by n square. Correct? Is less than. Same thing you write here. This is same. And this is, you can take r common here once again. R if you take out 1 plus 2 plus etc. n. That is summation of n. Correct? Summation of n. This is summation of n formula. Sum of the first n natural numbers, n into n plus 1 by 2. Here also n into n plus 1 by 2. And I'll take limit also for all these things. Take limit n tends to infinity for this. Take limit n tends to infinity for this. Take limit n tends to infinity for this. Take limit n tends to infinity for this also. Integral value of r plus integral value of 2r plus etc. integral value of nr divided by n square. Take limit n tends to infinity for this also. Limit n tends to infinity. Correct? So here see n cancel here. Correct? 1 by n remains. When you apply limit for this n tends to infinity, 1 by infinity is 0. This will become 0. And this is summation of n formula, n into n plus 1 by 2. I'll write here. That's equal to what I'm getting here. Limit n tends to infinity, correct? R into summation of n formula, n into n plus 1 by 2. N into n plus 1 divided by 2. That 2 comes to denominator. Divided by 2n square, I'll write. Correct? Minus, this part is 0, correct? 1 by n. N tends to infinity, 1 by n becomes 0. I won't write that 0, otherwise I'll write this like minus 0 here. Okay? Less than. Limit n tends to infinity. What we have? Integral value of r plus integral value of 2r plus integral value of nr, correct? Divided by n square, correct? Less than or here it is less than or equal to, less than or equal to. Less than or equal to what we have? Same thing here also, summation of n formula. Limit n tends to infinity. Limit n tends to infinity, what we have? R into summation of n into n plus 1 divided by 2. That 2 comes to denominator n square. Correct? Now you see, here if you multiply n into n square, the degree of numerator is 2. Correct? If you concentrate on this, the degree of numerator is 2 and degree of denominator also 2. So both numerator, denominator are same degree. So what is the limiting value? Limiting value is nothing but coefficient of n square in the numerator by coefficient of n square in the denominator. Coefficient of n square is r here. So r by 2. Here coefficient of n square is 2. R by 2. Correct? That is what we got. What about this? Here also n into n square. Coefficient of n square is r. So this value will become equal to r by 2. Correct? Coefficient of n square is 2. Coefficient of n square is, here coefficient of n square is r. Coefficient of n square is 2. So r by 2. So this is becoming r by 2. This is also becoming r by 2. So this expression is a sandwich between this and this. Both of these are becoming r by 2. So limiting value of this is also equal to r by 2. Answer is r by 2. Option D is answer. Hope you understand. Using sandwich theorem. And the question can be asked in the modified form also. I'll write the question if you want. Instead of greatest initial value of r plus greatest initial value of 2r, etc., greatest initial value of nr by n square, I can give the question in the modified form also. I can write the question like this. Instead of r, now I can write 1 square into r. I'll write the question here if you want. I'll write the question here. See, limit n tends to infinity. Limit n tends to infinity. They can ask the question like this because it is found in many books. Greatest integer value of 1 square into r plus greatest integer value of 2 square into r. plus etc. greatest integer value of n square into r divided by n cube. Okay, instead of 1 2 3 etc. n are given 1 square 2 square etc. n square. What is the answer? Answer is n by 3. Directly I can tell r by 3. Answer is r by 3 for this. Just directly shortcut. I can take it as a shortcut. Or is instead of asking if I ask 1 cube, instead of 1 square 2 square etc. n square, I can give 1 cube 2 cube etc. n cube r. That also, in that case also we can write, but denominator will be in that case n power 4. If you want to write one more slide here, add one slide here for you. Limit n tends to infinity, you can note down this. Limit n tends to infinity, what we have, greatest integer value of r plus greatest integer value of 2r etc. greatest integer value of nr, correct, divided by n cube divided by n square. We got the answer as r by 2. Suppose the question is limit n tends to infinity, integral value of 1 square r plus greatest integer value of 2 square r plus etc. greatest integer value of n square r divided by n cube. Here answer will be r divided by 3. Likewise, I can give one more question. It's not so far these two. I'm just giving an example so that you can understand better. Also, you can take it as a shortcut here. Integral value of 1 cube r plus integral value of 2 cube r plus etc. integral value of n cube r divided by n power 4. What is the expected answer? Can you tell? What is the expected answer? We'll get in terms of r only. R by what? Numerator will be sigma n cube. Sigma n cube is n square into n plus 1 the whole square by 4. Correct? So answer will be r by 4. R by 4. Can take it as a time saving result. Can take it as a shortcut or a time saving result. If it is asked in the exam, this is already asked. These two are not asked. If it is asked directly, you can crack it in less than 5 seconds. Okay. How do you get this actually? Here we got in the end the summation of n, no? Summation of n by n square. After using all those sandwich theorem, etc., 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 we got limit n tends to infinity. The trick is this, limit n tends to infinity. We got summation of n, correct? Summation of n divided by n square. Here we'll get limit n tends to infinity, summation of n square divided by n cube. Here in this case we'll get limit n tends to infinity, summation of n cube divided by n power 4. If you remember these answers, that is what we have in terms of r into half, r into 1 by 3, r into 1 by 4. Here how we got, see, limit n tends to infinity, summation of n what we had, n into n plus 1 divided by 2, right? 2 comes to denominator. Coefficient of n square is 1. Coefficient of n square, the denominator is 2. So 1 by 2. Here summation of n cube is what? Summation of n cube formula. Summation of n square formula, sorry. N into n plus 1, 2n plus 1 divided by 6. That 6 will come to denominator, correct? Becomes 6n cube. Here if you multiply n into n, I'll get n cube. What is coefficient of n cube? 2 in the numerator. What is coefficient of n cube in the denominator? 6. 2 by 6, 1 by 3. And here limit n tends to infinity. What is the formula for summation of n cube? Summation of n cube is n square into n plus 1 the whole square divided by 4. Correct? 4 n power 4. Correct? Here if you multiply, if you open this bracket, n square into n square, n power 4. Coefficient of n power 4 in the numerator is 1. Coefficient of n power 4 in the denominator is 4. So 1 by 4. 1 by 4 is the answer. So r by 4, r by 3, r by 2. Hence we get this. Please make a note of this important trick. In the exam you can evaluate directly. Many more questions we'll solve, not only PYQs of JEE exams we are solving. After completing, we'll solve even some of the important questions, most important questions which is not appeared also from various books. Okay, it might be Singhage or Arihant or R.D. Sharma or any other books which is available in the market. Hope I understood this. Solution is given to you here. Move on to the next one. Question number 15. Limit x tends to 0. Sin inverse x minus inverse x by 3x cube is equal to L. Find the value of 6L plus 1. Question asked on 18th of March, first shift, 2021. So if you apply limit directly, sin inverse of 0 is 0, tan inverse of 0 is 0, 3 into 0 cube, that is also 0, 0 by 0 form. We can apply L'Hopital's rule, you might get the answer, but x cube is there and you must know the formulas. If you are applying the L'Hopital's rule, you must know the derivative formula for sin inverse x and tan inverse x. Derivative of sin inverse x 1 by root of 1 minus x square. Derivative of tan inverse x 1 by 1 plus x square. All those things you must know. And you have to simplify more. You won't get the answer so easily. So instead of applying L'Hopital's rule, I'll use series expansion for sin inverse x and tan inverse x. Apply series expansion. Okay. Limit x tends to 0. What is the series expansion? For sin inverse x and tan inverse x. I'll write until we get x cube. Afterwards it's not required because denominator is containing only x cube. No. So higher power is not required. Higher powers of x not required. After x cube we write. Sin inverse of x expansion will be, expansion for sin inverse of x will be x plus 1 square into x cube divided by 3 factorial plus 1 square into 3 square into x power 5 divided by 5 factorial. Like this it goes on up till infinity. Sin inverse of x. And tan inverse of x expansion is x minus x cube divided by 3 plus x power 5 by 5 minus alternate plus minus etc. up to infinity. Writing the series expansion for sin inverse x and writing the series expansion for tan inverse x. All these things are given in the synopsis. You can refer to that. In the synopsis, I've explained all the series expansions for sin inverse x as well as tan inverse x. Using Maclaurin series expansion, you can reduce if you want. If you forget, simplify this. X and minus x will add up to 0. Collect the terms with x cube here. Limit x tends to 0. Limit x tends to 0. X cube common, correct, from these two. 1 square is 1, 3 factorial is 6. 3 factorial 6, so 1 by 6 I'll get. Here, minus into minus will be plus 1 by 3 divided by 3x cube, correct? X and minus x got cancelled. X power 5 if you are writing, x power 5 into something divided by 3x cube. Likewise other higher terms, correct? Here x cube is going to cancel. Here x cube cancels, x square remains. Limit x tends to 0 is there. So when you apply limit for this 0, 0 into something is 0. Similarly, all other terms are going to become 0. X power 7 by x could be x power 4. X power 4 into something. X is approaching 0. So x power 4 will approach 0. 0 into something 0. From here onwards, all the terms are dead, become 0. So what is left is 1 by 6 plus 1 by 3 divided by 3. Correct? LCM of 6 and 3 is 6. 6 into 1. So 1. 3 into 2 to 2. So divided by 3. So we get 3 by 6 by 1 by 3. It is 1 by 6. Correct? 3 is going to cancel. We get 1 by 6. So value of L is 1 by 6. We got L equal to 1 by 6. They asked to find 6L plus 1. 6L plus 1 is equal to 1. 6 into 1 by 6 plus 1. 6 into 1 by 6 is 1. 1 plus 1 is equal to 2. Required answer is 2, option E. Learn the series expansions for sin inverse x and tan inverse x also. Option E is answer. Detailed solution is given to you. 16th one, limit is there, integration sign is there. That means it is a combination of L'Hopital's rule and Newton-Leibniz formula. Shall we apply directly? See, if you apply limit directly, denominator is becoming 0, 0 cube 0. Numerator is becoming what? 0 to 0. Correct? Into lower limit is 0, upper limit is 0 square 0. So takes 0 by 0 form. Takes 0 by 0 form. Apply L'Hopital's rule. Differentiate numerator and denominator separately. Limit x tends to 0. What we have? D by dx of integral from 0 to x square sine root t dt. Denominator also differentiate. D by dx of x cube. Differentiate numerator and denominator separately. Integration and differentiation will cancel out by using Newton-Leibniz formula for the numerator. What we get? Limit x tends to 0. Integration and differentiation is going to cancel out. Substitute the upper limit, differentiate the limit, sine of root of x square into derivative of x square 2x minus sine 0 into derivative of 0 is 0 divided by derivative of x cube is 3x square, correct? Sine 0 is 0, 0 into 0 is 0. Root of x square is mod x is x, assume that x is positive here. So this becomes limit x tends to 0, what do you get? 2x into sine of root of x square, right, x divided by 3x square. 1x is going to cancel. So what is left? Limit x tends to 0, 2 by 3 into sine x by x. Sine x by x is 1 as x tends to 0. Sine x by x is 1, correct? 1 into 2 by 3, that is equal to 2 by 3. Option E is answer. Simple one. Applying L'Hopital's rule, differentiate numerator and denominator separately, and the numerator you apply while differentiating the definite integral, apply the Newton-Leibniz formula. Already Newton-Leibniz formula is also taught in the synopsis part. Synopsis part you become strong, then only you can work out the problems easily. First learn the formulas thoroughly, write and study the formulas whichever is taught to you, okay, and apply those formulas. Answer is option A. Please make a note of this. Next one, question number 17. Limit n tends to infinity, 1 plus 1 by 2 plus etc. 1 by n divided by n square whole power n is equal to how much? Question asked on 25th of February, first shift 2021. If you apply limit directly, this is something by infinity, correct? N tends to infinity means n square also tends to infinity, correct? As n tends to infinity, n square also approaches to infinity. So this becomes numerator is some number just greater than 1, I can tell, correct? It may be greater than 1. So 1 by infinity, that is 0. It becomes 1 plus 1, some number it is, okay? You can write some number infinity to the power infinity. Some number by infinity means 0. So it becomes 1 to the power infinity form. It takes 1 to the power infinity form. This is, so I know the formula f of x or g of x as x approaches, if it takes 1 to the power infinity form, what is the formula we have? E power limit g of x into f of x minus 1, right? E power limit n tends to infinity, the power you write first into base minus 1, 1 plus 1 by 2 plus dot 1 by n divided by n square minus 1. E power limit g of x, write the power first into the base minus 1, plus 1 minus 1 cancels, will add up to 0 here, correct? So what is the dot? E power limit n tends to infinity, correct? What is the dot is this n no gets multiplied to 1 by n square, 1 n will cancel, 1 of the n will cancel, that is 1 plus 1 by 2 plus 1 by 3 etc. dot 1 by n is divided by n, like this we get. And numerator is some finite number because 1 plus 1 by 2 is 0.5, 1 by 3 is 0.333, 1 by 4 is 0.25. It is a number greater than 1. It may be some finite number I can call by infinity, some finite number by infinity because n is approaching to infinity, no? Denominator is quite large. So some finite number by infinity is 0. So it becomes e power 0. E power 0 is 1. Answer is 1. Option C. Simple question asked on 1 to the power infinity form. Many times questions are asked on 1 to the power infinity. It's quite important. Sandwich theorem rarely asked. Okay. 1 to the power infinity frequently asked. Series expansion, L'Hopital's rule, Newton-Leibniz formula. These 4 very important. And also limits involving the modulus function and greatest integer function. All those things, you practice it properly. I'll be covering all the PYQs of limits. Then I'll go to the synopsis part of continuity also. Slightly climbing up limits, then continuity, then differentiability, and finish the calculus part, then go on to other topics, geometry, then also trigonometry we got, then we got algebra, various topics. Will touch all the topics, we'll cover all the topics so that it's useful for you to prepare. Solution is given to here if you want to make note of this. Move on to the next one. I think this is the last question session. the value of limit h tends to 0, 2 into root 3 sine of pi by 6 plus h minus cos of pi by 6 plus h divided by root 3 h into root 3 cos h minus sin h is equal to how much? Question asked on 26th of February, first shift 2021. The more questions were discussed in this session because in 2021 they conducted 4 times the JEE exams, once in the month of February, next in the month of March, then in the month of July and in the month of August. 2021 we had a devastating COVID wave in India, second wave we call. So very lockdown was there during that time. So they didn't get enough of applicants. Many of the students missed the JEE exams during the COVID period. So they conducted 4 times. Normally they conduct the exam two times, once in the month of January and another in the month of April. But in 2021 they conducted 4 times. 4 sessions were there. 4 phases were there, I can call. So here if you apply limit directly, it becomes 0 by 0 form. If you want to apply h equal to 0, no? Pi by 6 plus 0, pi by 6, sine pi by 6 half into root 3 by 2, pi by 6 plus 0, pi by 6, cos pi by 6, root 3 by 2, root 3 by 2 minus root 3 by 2, 0. Denominator h is becoming 0, everything is 0 there. So it takes 0 by 0 form. But applying L'Hopital's rule is not so easy here. So I'll avoid using the L'Hopital's rule. Okay, takes 0 by 0 form, takes 0 by 0 form, but I'll avoid using the L'Hopital's rule. Instead of that, I'll make use of the trigonometric simplification, the compound angle formula, because you see the angles are same, no? Pi by 6 plus h, pi by 6 plus h. I'll make use of the trigonometric formulas here. Okay, limit h tends to 0, limit h tends to 0, 2 is a constant that you keep as it is. Okay, what we'll do is in the numerator divide by 2 for both the terms. Okay, in the numerator root 3 is there, no? Right, that's root 3 by 2 into sine of pi by 6 plus h minus 1 then cos pi by 6 plus h into 1 I can consider, no harm. So I'm dividing by 2 for both the terms of numerator. I can use the compound angle formula. Why I'm dividing by 2? Because you're familiar with the numbers root 3 by 2 and 1 by 2, right? Root 3 by 2 and 1 by 2 can be expressed in terms of sine and cos. Root 3 by 2 is cos pi by 6 and 1 by 2 is sine pi by 6. Correct? I use those. That's why I'm dividing by 2 for both the terms of numerator. Denominator also I'll do the same thing. Root 3 h into here. Otherwise you can keep as it is, this term. If you want you can divide by 2, or else if you don't divide by 2, it should balance it by multiplying by 2. Don't forget that. So what we can do is I'll divide by 2 here. Okay, divide by 2. So that I divided by 2 for numerator as well as denominator. This you can keep as it is. Root 3 cos h minus sin h. Okay. Now this root 3 by 2 I'll write it as cos pi by 6. And this 1 by 2 I'll write it as sin pi by 6. Correct? It takes the form sin a cos b minus cos a sin b, which is sin of a minus b. Correct? This 2 will go up. Correct? This 2 will get multiplied with this 2. 2 into becomes 4. 4 by root 3 I'll keep outside. 3. Limit h tends to 0. What is left out here? Sin pi by 6 plus h into cos pi by 6. Correct? Sin pi by 6 plus h into cos pi by 6 minus cos of pi by 6 plus h into sin pi by 6. Correct? And this denominator is there, no? I'll apply the limit separately for that. Limit of f by g, limit of f by limit of g, or limit of f into g, I'll treat. Limit h tends to 0. I can apply a limit for that because there is no harm in applying that. It's a denominator, so I'll write 1 by root 3 cos h minus sin h, like this, applying limits separately. Divided by 1 h is there, don't forget that. Divided by this h is there. This 2 is taken up, 2 into 2 is 4. 4 by root 3 is constant, kept outside the limit, divided by h. Now, numerator is what? Here, limit h tends to 0. Limit h tends to 0. This takes the form sin a cos b minus cos a sin b. This is angle A. This is angle B. Angle A is pi by 6 plus h. Angle B is pi by 6. Sin A cos B minus cos A sin B, which is sin of A minus B. Correct? Sin of pi by 6 plus h minus pi by 6. divided by h. And for this, I'll apply limit directly here. Apply limit directly for this. Cos 0 is 1 and sin 0 is 0, correct? As h tends to 0, h is approaching 0, cos 0 is 1 and sin 0 0. So what this becomes is 1 by root 3 into 1, root 3 minus 0, correct? Root 3 minus 0. And here pi by 6 will cancel. Sin h by h. Sin h by h is 1 as h tends to 0. So what is left out here? 4 by root 3 into 1 into 1 by root 3. So answer is 4 by root 3 into root 3 is 3. 4 by 3 is the answer, option B. Hope you understood this. Simplification. Should not take more steps. Always practice with less number of steps. Do mind calculation. Majority of the steps has to be saved. Then only you can finish the paper. For maths, you need to keep 1 hour 20 minutes to finish off the paper. Okay, 25 questions will be there. 20 questions are multiple choice questions with single correct answer, and 5 questions are numerical type questions. If you practice more number of questions every day, you need to practice minimum 10 questions. If you practice 20 questions also, well and good. That much of time you should keep for practicing. Okay, then only you can do well in the exams. Solution of this is also given to you if you want. Solution is given in a little different way. I solved in different way. I divided by 2 for numerator as well as denominator also. I changed a little bit of steps here while solving there. Anyway, answer is same. This is a little lengthy, that is much shorter. Okay, if you want to make a note of this. With this, we can conclude this 2021 JEE. Okay, we finished all the questions of 2021 session. Okay, please subscribe to my channel. Those are not subscribed, please tell other friends, students also. It's very useful. Even for teachers also, this is useful. Okay, I'll be doing all the PYQs of JEE first, and also synopsis part. CET also will cover. NCERT book, NCERT examiner book also I'll be doing. KCET also will do. All different competitive exams will discuss the previous year questions. That's most important. Previous year questions if you work out, because that is most important, because you'll get the idea how the questions will be asked, what kind of questions, what level of questions will be asked in the exam, will come to know. And same type of questions many times it repeats. That's the important thing. Once you complete PYQs, then you can go to other questions. Okay, so first thing you should, if you're preparing properly, means study the synopsis part strongly and then study the PYQs. Practice the PYQs. If you're done with these two, then we can go to other questions. Okay, with this we'll conclude. Thank you.